I'm Anil Kumar, and in this video I'm going to discuss piecewise functions with you. We'll start with a very basic concept. So let me sketch a piecewise function and then we'll discuss about it. So that's the coordinate plane. When we are saying piecewise function, then we are trying to find two different pieces which could make a function. I should say two or more. So I'll sketch two different functions here. One, let us say this is a parabola, right? So let me say this is a parabola. And then let's have a combination of parabola with a straight line. So let me just start a straight line from a different point. So let this be the straight line. So what I've done here is that in this domain where x belongs to real numbers, I have two pieces of functions. So whenever you have two or more pieces of functions, then we call it a piecewise function. As you can see, it is a function since for every element in the domain, every element in the domain means all x elements here are associated with a rule to exactly one element in range, right? Let us say this point here is 1. Now at 1, this filled in hole means that the piece which looks like a parabola here ends at 1, and this point has a value 0. So 1, the value of the function at 1 is 0. The other piece starts at 1 on the right side of 1, and let us say this value here is, we can say it is 2. Okay, so if I put this value 2 and I have a hole which is not filled in, that means at 1 the domain of the second function does not include 1. At 1 it is the parabola which we need to consider, right? So these two pieces are kind of joined at 1 with a discontinuity, and this type of discontinuity which you see here will refer this to be as jump discontinuity. So the example which I have taken here is of two different pieces which do form a function but not a continuous function, right? So that is kind of an example which I have taken. Now, as you know, this is a function. We can always have a rule which will assign every element in domain to exactly one element in range. So the way to write the rule is, we can say this is f of x is equal to, since there are two pieces, so we just make two pieces, right? One piece is on the left side of 1, so we can say this particular piece which is on the left side of 1, let me say here, when x is less than equal to 1, then it's a parabola. You can actually find the equation of the parabola. Let us say this point is minus 1, and for simplicity I'm taking this as the vertex at minus 1. So now it becomes a parabola which has been moved or translated 1 unit down. So I can write this equation as x squared minus 1. So on the left side of 1, including 1, the function is x squared minus 1. On the right side of 1, we have a straight line. Now this straight line starts at 2, 1, 2, right, and then moves on. Let us say that the slope of the line is 1, right? And if the slope is 1 of this line, so y equals to mx plus b, we could actually say this point here is, let us say 1, 2, and we can have another point here which, let us say, is, when we are saying its slope is 1, then the other point will be 2, 3, correct? Now using these 2 points you can find equation of the line. Y minus, you can use for example this point, y minus 2 is equals to slope. Slope is y2 minus y1, which is 3 minus to divide by 2 minus 1, that is the slope, 2 minus 1, times x minus the x value. Is that okay? So rearranging this particular equation, which is in point slope form, you could always find the slope. So 3 minus 2 is 1, this is also 1, we get this as x minus 1, or we can say y is equals to x plus 1, correct? So if you even extend this line, it will have a y-intercept at 1. We have this equation of the line as the function f of x is equal to x plus 1 when x is greater than 1. Well, there are different techniques of finding equations of a function. You could use the 2 points and find equation of the line, starting with slope-intercept form also. Anyway, what I'm trying to say here is that in the function which we have considered, we have two different pieces. And these two pieces form one function. We are saying f of x. On the left side of the value x equals to 1, including 1, the function is a parabola, x squared minus 1, and on the right side it is x plus 1, so whenever x is greater than 1. So that is the piecewise function. Now in this piecewise function, if you need to find the value of the function, let us say at minus 1, how will you find? At minus 1, you can read from the graph it is 0, right? So we know it is 0. The other alternate way is to find algebraically. So let us see how to find value of the function from the given equation. Left side of 1 is minus 1. That means x less than equal to 1. So we have to follow this equation. So f of minus 1 should be x squared minus 1. So instead of x squared, we need to put minus 1. So in x squared minus 1, I am going to substitute minus 1 for x, correct? So what we have here is 1 minus 1, which is 0. So algebraically, that is how you find the value. Is that correct? Now, let us see how to find value of the function at, let us say, point 3. To find the value of the function at 3, we know 3 is on the right side of 1, and therefore the piece of the function which is on right side of 1 is given by the equation f of x equals to x plus 1. So we'll use the equation x plus 1, and in this equation we'll substitute x as 3. So we'll write 3 plus 1, that gives us a value of 4. So we know that f of 3 is equal to 4. You get the idea, right? So that is how you can actually evaluate value the function at any given point in the domain of this piecewise function. Now here is a question for you. What is the value of the function at 1? At 1, you can see from the graph, when x is less than equal to 1, we have to follow x squared minus 1, right? So let me substitute here. We get 1 squared minus 1, which is indeed 0. And from the graph also, the filled in hole is at the x-intercept. So the value of the function at 1 is indeed 0. I hope that helps you to understand what basically a piecewise function is and how can we find value of the function at different points. Now here is an exercise for you. Let me give you a piecewise function which has 3 pieces. Let's say that is the first piece. The second piece is a line which is slanting downwards, let's say like this. And the third piece, let me draw with a different ink, is this horizontal line, right? So, and let's say the function actually starts from here only, right? So that is the function which we have. Now the exercise for you is to write down the equation of this piecewise function. Let us say this value is minus 2, and let's say this value is plus 4, and here let me say this value is 2. Now given these points, I think it should be not very difficult for you to write down the equation for the piecewise function, right? So I just created one. So remember, in this piecewise function, we are looking for three different pieces, right? So you should write in like three different pieces. One is when x is between -2 to 0, right? So when x is greater than equal to -2 and is less than 0. You could include 0 in any one of these pieces, right? So you could include 0 in any of these pieces. The other domain part where the second piece is between 0 and 1. So we can say between 0 and 1, but include it only with one of them. And then we have when x is greater than, you could say less than equal to 1 for this piece, so include both pieces on this side. And the third, you can say when x is greater than 1, right? So write down these three functions, and these three functions combined gives you the piecewise function. And for this particular function, I like you to also mention what is the domain and range, right? Now here, the domain is x belongs to real numbers, right? All real numbers are included. However, the range in this particular case is y belongs to real numbers, where y is greater than equal to -1, and so we could write this as where it is between -1 and, so this, because 0, everything is included, so we can say y is, so y is, we can say greater than equal to -1. Okay, so that is how we can find range, because this area which is jump discontinuity is covered on the left side, right? So range is y greater than equal to -1, domain is all real numbers for our piecewise function. Similarly, write down domain and range for the other function. Okay, so that is an exercise for you. We'll take up a video where for the given function we'll see how to find equation. I hope that helps. Thank you and all the best.